Good day, students. How are you? So today we are having chemistry. For those that are new to our class and to this course, so this is extreme scientifics. They are called extreme scientifics. So we've been dealing with different science topics, starting from physics, chemistry, biology. I also deal with the maths and further mathematics because you will use them in solving complex equations. Are you understanding me?
Yes.
Good. But today we are introducing chemistry. What did I say?
Chemistry.
We are introducing what?
Chemistry.
Chemistry. So as you can see, I've wrote a lot of things on the board in introducing chemistry. So this is part one. So under that part one, we have just a brief summary of everything we are to treat in chemistry. Which are those things that will come out in your WAEC, GCE, NECO, NAPTEP, and even your JAM. So they are the things that you set question on. Are you understanding me? Mhm. So mainly in chemistry we have physical and inorganic chemistry. What do I call it?
Physical and inorganic chemistry.
Very, very physical and what? Inorganic chemistry. So then the next one is called organic chemistry. After organic chemistry, we have what's called radioactivity. What do I call it?
Radioactivity.
Then the next one is called metal and alloy. What do I call it?
Metals and iron.
The last but not the least is called chemistry of earth and what?
Space.
And space. You know, chemistry is not only studied on this planet alone. We have other planetary bodies, right? Now I gave you an assignment yesterday when we were treating physics to go and study about a man called Elon Musk. So he has this goal and ambition to make everybody on Earth a multi-planetary living being. That is, as we are human being, we should be able to also be going to other planets and be living there. You know what I'm saying? So we should have to be a kind of a multi-planetary personality. We should have understanding about what? Planets. And we should not just only have understanding about planets, we should also go and live with those planets. So chemistry of earth and space is what will lead us into that. And that before Elon Musk starts his company, SpaceX, in the year 2002, right?
Yes.
You know, Elon Musk is from South Africa, as you exactly as you wrote in those books. So he has ambition and passion. You know what I'm saying? He learned programming, he loved the sciences. In fact, he left South Africa and traveled to Canada. From Canada, he traveled to the US. There's a place called Silicon Valley. What I got a place?
Silicon Valley.
Silicon Valley is a place where all the tech giants have their company. What did I mean by tech giants? Like Apple. Like who? You know, a lot of people are killing themselves because of Apple products. Like that might have is an Apple product. You know what I'm saying? So some people, because they want to buy iPhone 16 Pro Max, 17 Pro Max, you can do all sorts of things from Apple. So there's a place called Silicon Valley where Apple has their base. The same thing, Google has their base in Silicon Valley. The same thing, Samsung, they have their base in what? In Silicon Valley. So Elon Musk traveled to those places, he also was able to partner with NASA. Now, I've been discussing about NASA with you for from this now. Is it yesterday or the first day? Is it yesterday? So what I call NASA, National Aeronautical and Space Administration. So they are situated in the United States of America. So that department dealt mostly with space. You know what I'm saying? They did a lot of experiments in outer space. So all these things that we are enjoying today, like weather forecast, satellite, this thing you are in Nigeria, you be watching what is going on in football that is going on in Madrid, in England, in Paraguay, in Uruguay, in Chile, in Argentina. You be in Africa, you be watching those things. How was it possible? Through WhatsApp satellite. So all these people, they are doing a lot, they are doing well, they are doing a lot of good things that we are enjoying today, especially technology. So they are doing us good, fine, pretty technology. So chemistry of earth and space, we go deeper about things like what, like that. Now, and I begin to pick those topics one after the other. Physical and inorganic chemistry. So under physical and inorganic chemistry, so we will deal with a study of number one, say atom and molecules.
Atom and molecules.
Say atom and molecules.
Atoms and molecules.
Say atom and molecules.
Atoms and molecules.
So we will deal with the study of atom. We will kind of do justice to the theory of atomic theory, by this man named John Dalton. What do I call his name?
John Dalton.
What do I call his name?
John Dalton.
You are going to listen to the law of the atom that he supplied. So atomic theory is not the only one that work on the law of atomic theory. There are other people that also do their own part in working with the law of atomic theory, but is the first to propose atom. It's about atomic theory. So that's why we call it John Dalton. That's actually. So we will also learn about the structure of the atom. The structure of what?
Atom.
The structure of the what? So the next one, we're going to do what's called mass relationship. Sorry. Mass relationship of an atom. Mass relationship of what? Of atoms. So we will study it. The next one is called molecules. Atom in combinations. How atoms combine with each other to form a molecules. Are you understand? Good. The next one we're going to do is called laws of chemical combination. What did I call it?
Laws of chemical combination.
What did I call it?
Laws of chemical combination.
What did I call it?
Laws of chemical combination.
The next one we are going to do is under laws of chemical combination. Listen, in chemistry you follow laws. What I did? In chemistry you follow laws. For example now, you can do a particular experiment, homemade experiment. Imagine you boiling, you know when your mom is cooking at home, right? They will boil palm oil. They will turn that palm oil to pan with it. What does it mean? They will so boil that palm oil. It will be so hot. So they will not change the molecular structure of that palm oil, that red palm oil, into another thing else. Now, as that is very, very hot, what do you notice that we have if you are not careful? Good, clap for him. Yes. It will set on fire. And besides, imagine you don't want to put your pepper, your onions, and all these things. When you use your pepper and put it on top of that very hot oil, what do you think will happen? It make a loud noise. And what? and smoke and steam will come out. Why? Because that red oil is excited. Are you understand what I'm talking about? And as it's excited, once you now put those things there, it will react. Are you understand what I'm saying? It's engulfed into flames. You see smokes. Are you understand what I'm saying? Both the smoke and those other things, that the energy that was being released, they are part of what? The red oil that was boiled or set on fire. So there's a law that governs all these things. Something that is charged, you don't just put the lesser thing that's not charged on top of what? Of that thing. There will be a resistance. What did I mean? For example, now look at me. Don't be distracted. Look at me. Somebody that is strong, somebody that is weak, now going to be attacked somebody that is strong. What do you think? Eh? What is it?
Strong one.
The strong one what? Defeat the this thing. There will be a strong resistance. So under the law of conservation of mass and energy and all this stuff, you will be able to know how to add chemicals. Are you understand what I'm saying? You will be able to know how they release energy. It's called enthalpy and what? Entropy. We go into that. Are you understand what I'm saying? We go into that. All the stuff. How photocopier machine works, kind of one is here. By releasing photon. All these things. We are going to go into that law of conservation and conservation of what? Energy. Then the next one we have what's called law of definite proportion. What did I say?
Law of definite proportion.
What did I say?
Law of definite proportion.
Good. Law of definite proportion. The next one is called law of multiple proportion. What did I call it?
Law of multiple proportion.
What did I call it?
Law of multiple proportion.
Law of multiple proportion, not promotion. We are not putting being quotient here. Proportion. Good. So next one, we are going to deal with quantum theory. What did I say?
Quantum theory.
This theory, you have to just know it. Once you know it, you'll be able to have understanding of the technology of the future. That's called quantum computing. You know what I'm saying? You know how quantized energy flow from one location to another. You will also have understanding about how network works. You are here, you call somebody, hello. How does that your voice reach the other person? So you understand it's called quantum theory. Are you understand? And the electronic structure of atom. And the what? Electronic structure of atom. Now, under it we have number one, Bohr's theory of the hydrogen atom. What do I call it?
Bohr's theory of the hydrogen atom.
I will give you another assignment to go and research about this man. His name is called Niels Bohr. What do I call his name? Niels Bohr. What do I call his name? He's from Germany also. Go and do research about it. Niels Bohr. What do I call his name? Go and just as you do research about Elon Musk, go and do research about who is Niels Bohr. Who is what? Niels Bohr. So go and do research about this man. That's your assignment. Now I gave you 2 assignments yesterday. What's the second assignment? Completion table. Is there no other assignment? Good. So go and do research about Niels Bohr. What are those things that he discovered? I understand what I'm saying. So we are going to say Bohr's theory of hydrogen atom. Then next week we are going to study what is called emission spectrum. What do I call it?
Emission spectrum.
What do I call it?
Emission spectrum.
What do I call it?
Emission spectrum.
Good. The next one is emission of hydrogen atom. What do I call it?
Emission of hydrogen atom.
What do I call it?
Emission of hydrogen atom.
Good. Next one we have what's called applying Schrodinger's equation to the hydrogen atom. What do I call it?
Applying Schrodinger's equation to the hydrogen atom.
Good. Let me go around. Go and look for go and study about this man. Schrodinger. That is this thing, but I forget his first name. Schrodinger. This man too is a very good scientist. Go and study about drugs. This man. You understand what I'm saying? All those things that he discovered. So go and study about it. Schrodinger. The next one, we have Schrodinger's equation to the hydrogen atom. The number 5, that was called quantum numbers. What did I call it?
Quantum numbers.
I'm going to study about that. All these things, prepare your mind. What did I say?
Yeah.
Good. The next one, we have the principal quantum number. What did I call it?
The principal quantum number.
Number 2, we have the angular momentum. What did I call it?
The
angular momentum.
Or the angular momentum quantum number. What did I call it?
The
angular momentum quantum
The next one we have what's called the magnetic quantum number. What do I call it?
The magnetic quantum number.
Next one we have what's called the spin quantum number. What do I call it?
The spin quantum number.
The last but not the least for this number 6, the atomic orbitals. What do I call it?
The atomic orbitals.
The energies of orbitals.
The energies of orbitals.
I'll write the part 2. I'll continue from the right step. When you are when we start. But what I want to bring out from all this thing, if you understand all this thing, you need to know about orbitals, how to number an element based on their orbital shell. What I got this? Orbital shell. So you'll be able to know how to do what's called key element O orbitals. So you'll be able to feel this thing. Then you have to know what is called SDDF. Yeah. Spin, diffuse, principal, and fundamentals. You understand what I'm saying? So all those things you'll be able to know how electron feel each shell. You can't see electron with your naked eye. Can you touch that electricity that's going on outside? It will not shock you. You can't see it, but it's operating there, right? But if you touch it, it's going to shock you. Why is it shocking? It's containing stream of what? Electrons. We have the positive and we have what? The negative. Mainly, most times, electrons are always negative. But due to the inner particle inside the electron, called the proton, and the what? Neutron. So, electron can be positive or it can be what? Negative. Based on the outer electron in the shell. For example, now, there's an electron that are positive, that are extremely very hyperreactive. So, under this topic, we are going to study all of them. How they behave. Are you understand what I'm saying? How they do what? How they behave. That's why in science class, as I told you yesterday, you don't misbehave in science class. You don't underestimate all those materials like electrons, chemicals. You don't underestimate them because some of them are extremely very dangerous. What did I say?
Some of them
They
are
are extremely very dangerous.
So they are hyperactive. What did I say?
They are hyperactive.
Some of them are like that. Some of them are very hyper-reactive. What did I say?
Hyperreactive.
Once you react them with something like it can explode. Now, why? Because they are very hyper-reactive. For example, like sodium. That's why sodium, you can never always find sodium alone. You can never always find sodium alone. It's very hyperreactive. If you kind of react sodium with water, it will explode. The same thing, fluorine is very reactive. Where can you find your fluorine? Inside your toothpaste. But it is reacted with other substances. But fluorine alone, it will kill you. It's very reactive. It is negative. but very hyper what? Reactive. It's looking for something to react with. So we will study all those things under atomic orbitals, quantum number, all this stuff. We are going to study them. You know the behaviors of electrons. You also know about protons. You also know about what? Neuron and neutron. I know what I'm saying. So about electron, proton, and what? Neutron. Those are the first fundamental parts for your level now. There's other particles like quark, meson, gluon, baryon, hyper this thing, hyperion, all these fundamental particles. There are very many. You know what I'm saying? So to when we do the study of antimatter, those one are too higher for your level now. I hear what I'm saying. So this once you know this one, when we get to those higher levels of theory and experiments, you'll be able to understand how these things operate and how they work. Any question? So the little bit later when you come to class, you ask questions. Any questions? Huh? There's no question. There's no question. Are you sure? No problem. So I'll stop this part one now. So when we erase it, we start action.
Sure. God bless you.